Hello friends, in earlier video we discussed the theory of how to do the bias evaluation and knowledge based testing. So let's do the practical and understand uh, on how to do the bias detection and knowledge based evaluation, right? So we will consider a example where a knowledge base vector embedding data has been stored into a knowledge base. So evaluation of bias is done at three stages. That is a pre-processing, that is which is a data set, bias analysis, and model evaluation. Right. Then we implement fairness constraints and create agents which are used in the multi-agent workflows, be it a voice agent or a agentic workflow solution. Right. So in data set analysis. Data is your input is given and evaluated on a large language model based on whether it's used for question answers kind of solution or summarization or code generation or question and answers and so on. Like so, for fairness constraints, we have guardrails and different libraries available to do the evaluation. In case of multi-agent workflow solutions, we have LangChain, LangGraph, LlamaIndex, and other libraries. So one of the agent can be a fairness agent, or every agent can have in it agent to do the fairness evaluation. Right. So how to test the knowledge base? The knowledge base can be just like we'll have huge volume, variety, and versity of data. So that data can be static data or inflow continuously coming, and with time you replace that data when the any changes happen in the content due to the law changes in the law or otherwise, right? So one cannot manually generate questions and answers for such a huge data. So how, with the help of agent, we can generate such question, sub-question tree along with the expected answers, right? And then for each question, then to do the robust testing, same question can be asked in the different forms of adverbs, nouns, verbs. Those question variations also can be created and tested. If you see the BERT score, whether the question is asked in a different way, but the cosine similarity is same, accordingly the answers given should be matching the expected answer and should be high on the confidence score, right? So once such evaluation is done for the questions and question variations for each document in a corpus, a bias scoring rubric can be created based on different criteria of bias, robustness, perplexity, fuzziness, and so on, and it can be visualized in the form of box plot or a chart on a scale, and so to do the evaluation, like take an example, and here it will also help to revise the skills of prompt engineering. So this is the prompt on creating the agent for an agent which will create the question tree and sub questions and its expected answer. So if you can create such agent in a NA10 or any no code platform, and you can give some small document as an input and check the output. Right. So here what the prompt says is create question and answers and its graphs of sub questions and answers. Along with that, all other questions please also include WH questions. Please create only the Python dictionary format in the CSV output, and so on. And then you also include the exemplar in which you specify how the output format should look like. Once we build a question, we can take one of this. For every question, we need to build a question tree. So for that, you can have another agent where each question is given as an input to build the question variations for it. Right? Like example, I want to arrange a meeting. Same thing can be said. I need an appointment. You can add a temporal. I need an appointment next week. right? Or you can say in the grammatically incorrect language, appointment please, right? So for generating such variations, we can create another agent, create the working variations of the given sentence, create different combinations involving verbs, nouns, adverbs, and adjectives. We can consider various ways to rephrase or expand the sentence, and so on. Please create only comma separated CSV output. Like the earlier agent, here also we can provide the example format of the output. Now once the questions are created, sub questions are created, question variations are created with the expected answers. Now when you run the solution, either whenever you are running a agentic workflow, whenever you get the answers and synthesizer, before synthesizer or after synthesizer, you have the output. Same output you can give along with the question, expected answer, and the answer you received. And you can have such agent to make the evaluations on the bias, perplexity, fuzziness, distortion, accuracy, outlier analysis, and so on, and also on BERT and BLEU, right, based on what kind of solution it is. Like BLEU is for language evaluation and translation, while BERT is for cosine similarity or keyword search similarity, what kind of comparison for evaluating the comparison. Right, so let's understand this prompt. Please compare the expected output to the actual output and score the answer on the scale of 1 to 5. Highlight if any of the following bias were detected in the actual output. Right, please evaluate the actual output for fuzziness, perplexity, distortion, accuracy. Actual responses on identifying bias for word rate analysis, outlier analysis, nuance data, and so on. You can pause the video and read it completely. Evaluate the actual response for toxicity, robustness, accuracy, coherence, relevance, fairness, and so on. Right? So, and then you can give an example of the output format in the order in which you need the columns and the sample values, how it should look for. Like, you can specify what is very biased or unbiased for you on the scale of 1 to 5 or any scale which you would like to have. Right? So this is what the three agents look like, and with this help of three agents, you can build a solution to do the knowledge base evaluation. The input can be based on the size of the chunking, based on the size of input data which a vector embedding model can take, like there is a AWS Titan model or OpenAI text model for generating vector embeddings, which can take up to more than 8,000 tokens and creates a vector embedding of 1,536 dimensions. Right? In your solution, how you are using cosine similarity or keyword search, or when you find a relevant embedding, you also pick the neighboring embeddings to construct the more robust and correct response. Accordingly, you can create a business logic for the input given to these agents and get the output. In a long-term solution, for the robustness to confirm that an agent is working as expected, one can create a AI-based Python or RStudio solution to do these evaluations for each of these attributes, and can compare with the agentic output to confirm whether both are working correctly. The other thing which can be done is LLMs are trained on different size and type of data. So one LLM which is doing the evaluation may give certain output. So for such confirmation, one can have 2 to 3 LLMs doing the same bias evaluation, and accordingly we can confirm that the output is similar and near the same for the same set of expected answer, question, and actual answer. Yeah. So same evaluation for large language models will differ, and we will consider that in a separate video much later once we do the learning of agentic AI. So let's understand. Like when you do a ad hoc testing, you will just ask randomly some questions and based on the data given to you, and try to test the solution, which will not be a a foolproof solution. So to make a foolproof solution of testing a knowledge base, you need to have a structured questions trees with sub questions for entire set of documents in a corpus. And then accordingly one can do the automated regression testing or the complete functional testing of it. Similarly, if it is a voice agent, the output of the voice conversation can be given to the same solution, and it can be evaluated. Only thing, the bias criteria, which is important, accordingly it should be used. If you write all in this sample solution, I wrote everything into a single agent, which will be time consuming and add to the latency. In the real-time solution, multiple agents can do this processing in parallel for different attributes, and then collect the information to reduce the latency. Right. So let's understand at which stage we can apply this evaluation. So suppose some source data is there which is ingested into the embedding model, and the vector database is created. And now with the help of cosine similarity, you retrieve the data whenever question is asked. It looks into the vector database and retrieves the answer and synthesize it. So those answers which we get, we can compare with the expected answer and do the scoring. Right. So vector embeddings, if you see, does the semantic clustering, and it finds the information based on semantic similarity. It looks for the vectors near to the question vector. So like if you say schedule an appointment, book up a meeting, see doctor, all it should based on the domain of the solution, it should all lead to the same answer and get the information. So this anytime when the documents are changed, these vector embeddings are replaced. The metadata mapping is taken care in the table where the new vector embeddings are created and replaced. So let's take an example. So when you build how to give the knowledge base document input to an agent, it will create a question. Along with that, it will create a sub questions, right? So based on who, when, how, all the different WH questions, it will create a different set of questions and get expected answers for them, right? So let's understand the question variation. So the appointment, whether you ask what is who is the appointment with, or you ask the same thing in a different way, when is the appointment, it should be able to retrieve and give the same information. Whether you ask in the to the agent to get from the tool API or from the knowledge base, right? So if we want to do the stress testing to do the evaluate the robustness and variations. So for each question, you create the working variations, grammatically incorrect language, failing variations, and then test using all of them. Like Shank's theory suggested, the verb valency, like in day-to-day life, a human does not speak grammatically correct language, so it should based on the noun, it should be able to identify the domain, and based on a verb valency, the main verb, it should be able to take the action, right? So then the advanced variations of the same question, schedule the appointment for this afternoon, so the temporal is added, schedule an appointment for tomorrow. So the agent under test should be able to understand it and accordingly identify the goal and additional information of the goal attributes it should be able to extract. Like in case of voice agent, if such information is given, and if still voice agent under test asks when do you want the appointment, then such information can be grabbed, and over the JSON object at the end of the conversation can be sent over the API call, and accordingly test management or bug management tool can be automatically updated. So when you create a bias evaluation agent, what all things you need to take care of, and different kinds of bias fall under which bucket. So gender bias, religion, cultural, human, all comes under demographic. Then industry bias, ascent bias, domain specific comes under systematic bias. Then observer, emotions, prejudice comes under cognitive bias. And algorithmic bias, pattern, favoritism comes under technical bias. And in addition, there are bias like historical data bias. So to do a lab exercise, as I mentioned, at the start of the session, I shared the agents. So in N10 kind of platform or any other platform, you create the agents and you give the sample questions and test it. Okay. So the first exercise, do the data audit, analyze different source data sets for distribution skews, and one can do the visualization in form of box plots or statistical analysis by drawing the charts. So the next exercise is implementing the fairness. So for that, if you are doing one is training the data model, and then other is removing the raw data into processed data based on removing the bias and right. So for that, different tools like Fairlearn and others are available. Okay, so in a workflow solution, if we want to implement the fairness and include the evaluation, bias evaluation, so like so suppose agent A, which is a generator which retrieves data and writes answer. Then the agent B, which reviews all the bias in the output generated, and then the next agent writes content, proposes strategy which mitigates the boundary conditions and evaluate the process data. So in these three stages too, the audit automation can be achieved. Sorry. Interface specifics, voice agents and chatbots. So in case of chatbots, either it could be a chat or the voice agent conversation. One can check how the system is responding, whether the response is correct, how many times the email greeting was done, how many times greeting was or how many times name was asked, address was asked, zip code was asked, or the phone number, and such information, if repeatedly asked at the end of the conversation, agent can send it using an API tool call to take the necessary action in the next stage. Okay. So how a question would be evaluated? So the question text is purpose of appointment. The actual answer is to meet doctor, and expected answer is to meet doctor. In that case, the score is 5 and the bias score is 1. So it performed as expected. In real-time scenarios, on an average, the answer would be around 3 to 4. So based on what kind of accuracy is required, the accordingly scoring is above 70% or 80%. It should be considered practically as expected. Like so, one is at the level of each question, how the behavior of on the different bias and evaluation is, and then at the combining values for output and the matrix values for each and every question in the document wise, the evaluation can be done, and finally at the corpus level for the entire solution. Okay. So other than bias, the important metrics one should evaluate is fuzziness, perplexity, distortion, and accuracy. So fuzziness is the providing the vague answer and not the exact answer, as mentioned in the uh, knowledge base or as retrieved by the SERP API. So it's trying to kind of not hallucinating or hallucinating. Perplexity is the model confused about giving the answers. Distortion is the meaning change from the source. So a certain sentence is mentioned in the source, though the way of a pattern of verb, noun, adjectives may change, but the meaning should not change. Accuracy, so factual alignment with the truth. So the response should be accurate, right? The different reasons for distortion could be also depends on the setting of large language models, like temperature and p-value and so on, where it's more generative and less deterministic, where it tries to create its own and predict the next word. Semantic similarity, automated scoring. So when to use BLU is used for translations multiple languages if solutions are supporting, suppose English and Spanish language. If there's a mixed communication using multiple languages, the agent is able to understand and translate it well or not. In such case, BLU score is required, and BERT is required based on matching the expected output and the actual output, and whether the answer is matching the question, because question is also converted into vector embedding, and accordingly the nearest vectors for those questions are retrieved to provide the response from the vector database. The next is response quality and metadata analysis. So you can have an agent where when you ask the question, you will get the response, and that response you can evaluate by using an agent whether the answer is matching based on what is the question asked, and do the score, right? So for this, the matrix which we can need to evaluate is coherence, relevance, and fairness. So when we do the start building a solution, we use certain model, then we add the knowledge base, and then finally you change the model, you do the different settings based on orthogonal array we create, and fine tune the responses where the score is 0.8 or above, which is practically considered to be the robust. So the evaluation checklist, what is the step follow? First, build a question tree, then build the question variations, then detect the bias, then quantify the output for different variations, and iterate these executions multiple times using different language models and different settings, preferences, and do the comparison and see the consistency after, and accordingly do the changes and fine tune it. So let's now solve the quiz and see how much we have understood. Please pause wherever required and see the expected answers and the hints. I will just run through and read the questions only. When implementing fairness constraints in a machine learning model using libraries like AIF 360, which metric is commonly used to evaluate the differences in outcome between protected and unprotected groups? Here is the options and here is the hint. Next question. In the context of designing an agentic workflow for bias detection, which frameworks are specifically recommended for managing multiple collaborating agents? So here is the option and here is the hint for finding the right answer. Next question. What is the primary purpose of including sub-questions within a question tree for a vector embedding knowledge base? Here are the options, and here is the hint. All these questions are also available on a LinkedIn blog, which I will share in the comments. The next question. When evaluating the robustness of a knowledge base, what do temporal handling variations specifically test? And here is the hint. Next question. According to the scoring rubric provided, which value would an evaluator assign to a system that provides only a generic event summary instead of a specific answer? Here are the options, and here is the hint. Next question. Which of the following matrix is used to provide a numeric measure of semantic similarity by comparing the actual answer to the expected answer? Here are the options, and here is the hint. The next question. Which specific type of bias listed in the rubric relates to favoritism or disadvantage based on industry specific standards or norms? Here are the options, and here is the hint. Next question. What is the primary reason for testing failing variations such as intentionally ambiguous or adversarial queries? Here are the options, and here is the hint. In the vector embedding evaluation exercise, which technique is suggested for visually inspecting the quality of embeddings? Here are the options, and here is the hint. Thank you, and